Hello. Today we are going to study Bohr's atomic model. Previously we have studied Rutherford atomic model. Rutherford in his atomic model could not explain the stability of atom and he could not explain the formation of line spectra or atomic spectra. But in the year of 1913, eminent scientist of Denmark Niels Bohr successfully explained the stability of atom and formation of line spectra, and his postulations are known as Bohr's atomic model postulation or Bohr's atomic model. In the very first postulate, he said that electrons cannot revolve around nucleus in any path of their own choice. Each electron has to follow a certain path having fixed radii which is available for revolution of electrons. So, no electron can randomly select a path and revolve around nucleus. So, now question arises, which path is available for revolution of electron? Mathematically, it is proved that only those circular orbits are available for electrons where the angular momentum of the revolving electron is equals to the integral multiple of h by 2 pi. We can see here angular momentum of an revolving electron is mvr and it is equals to the integral multiple of h by 2 pi, that is nh by 2 pi, where n equals to principal quantum number, and principal quantum number means serial number of orbits. The very first or very nearest orbit of nucleus is known as n1 and then sequentially n2, n3, etc., etc. And if this is nucleus and the first orbit, this one is known as n1, second orbit n2, this one, and the third most orbit n3, and like this it goes on. So, only those paths where the angular momentum of electron is equals to the integral multiple of h by 2 pi, only those paths are available for revolution of electron. No electron can revolve in any path of their own choice. This was the very first postulate of Bohr's atomic model. Now, the second postulate was that during revolution, electrons neither release energy or absorb energy. So, when an electron is revolving around a nucleus in a specific orbit or specific circular path, it neither release energy nor absorb energy. What does it mean? It means each circular orbit has fixed amount of energy. The orbit which is nearest to the nucleus has lowest energy and the orbit which is farthest or which is very far from the nucleus have higher energy. So, we know that the nearest orbit of nucleus is known as k orbit, next L, M, N, sequentially we name it, and so the very much important point is that the energy of k is less than L, energy of L is less than M, likewise. So, the important point is that the postulate says no electron during revolution throughout any orbit, neither it release energy nor it absorb energy. And the third most important postulation or points of Bohr atomic model was that when an electron is revolving around a nucleus, suppose it is revolving in orbit number 3. From this orbit, when it is jumping to the second orbit or to the first orbit, it releases energy. Similarly, when any electron is revolving in the first orbit or second orbit, it is jumping to the third orbit or fourth orbit, that means higher orbit, it absorbs energy. So, when any electron jumps from higher energy state to lower energy state, it emits radiation, and when any electron jumping from lower energy state to higher energy state, it absorbing electron. And during this emission or absorption, emission spectra or absorption spectra is formed. We can say that suppose electron is revolving in second orbit and its energy is E2, and when it is jumping to E1 it is losing energy, and the amount of energy loss is E2 minus E1. Scientifically or mathematically it is proved that change in energy due to jumping of electron from E2 to E1 is equals to h nu. So nu equals to E2 minus E1 by h, and E2 minus E1 can be represented as del H, as it is change in energy. So this is the mathematical presentation of third postulate of Bohr atomic model.